Okay, so let's solve this. We know px means minus I h cross del del x. So let's put it here. X into first we're solving this part. X into px square means minus I h cross square. Px square means del del x operate will be on del del x. This square means what? Minus I h cross square, and del del x will be operate on another del del x. Okay, shy. Minus px square means minus I h cross square minus I h cross square. Del del x will be operating on del del x. Del del x will be operating on del del x. Okay, del del x will be operating on, this will be px square, this is our px square, this is our px square into x shy, right? And here the tricky part is minus minus plus, minus square will be plus, I square will be minus, I square will be minus 1. So minus x h cross square minus x h cross square del 2 shy del x2 minus, sorry, minus plus h cross square minus plus I square means minus 1. So obviously there will be also minus. There will be also minus, isn't it? See here, minus minus is there. Minus square means plus, or I square means minus 1. So inside it's minus 1, outside minus 1, that is plus. Oh, okay, there will be plus. Okay. Okay. Oh, this will be minus, this will be plus. Okay, plus h cross square. Now we know operator operates on the next function. So this operator will operate on this. Here you can make big mistakes. Someone will write del del x into del del x means del del x square of x shy. Someone will do this. So, or some, this is not the correct way. First you have to operate this operator on this. Then overall this, we have to operate del del x. So square del del x into del del x of x shy. That means x del shy del x plus shy del del x. Shy del x means 1. Got it? Del del x of x shy. Solve it. We will get this. Now. Minus x h cross square del 2 shy del x2 plus h cross square del del x will be operate on this. Now it's the most significant part. Now this will be the most significant part. This portion, h cross square. Now this thing is the most significant part now. Del del x first will operate on this. X del shy del x. So first will be, this is like u, this is like v. So del del x will operate on uv. So first I am putting u, and then del del x operating on v. That means del 2 shy del x2. Del 2 shy del x2 plus, we will be putting v constant. That means del shy del x, we will be putting this constant. Then we'll be doing del del x into x. That means into del del x into x. This is 1, nothing but 1. Plus. So first del del x operated on this function. Now del del x will operate on this function. Del del x of shy. That means del shy del x. Now just simplify it. Minus x h cross square del 2 shy del x2 plus x h cross square del 2 psi del x2 plus uh, plus h cross square plus h cross square into del psi del x plus cross square del psi del x plus h cross square del psi del x, isn't it? H cross square del psi del x plus h cross square del psi del x. Got it? This portion cancel out. Then 2h cross square del x of psi. Clear? Then what we are getting ultimately? This means 2h cross square del x of psi. That means the value of this commutator is this 2h cross square del x. 2h cross square del x. Now question number 5. I will extremely strongly recommend you to do it yourself. Now we have to just a little bit simplify it. 2h cross square means this is fine, but I want to simplify it a bit more. X px square. Now this is the value of this operator, right? Now I will simplify this function. Simplify this commutator. Okay, x px square. Just write it like this, simplification. X px square. That means x comma px dot px. No issues. Then what was the rule? First we have to put it here. First px right here and px right here. Here one third bracket and here one third bracket. Here will be plus. There will be x comma px. There will be x comma px. Right? What is the value of x px operator? What is the value of x px commutator? What is the value of x px commutator? Let's see. What is the value of x px commutator? I h cross. X px commutator is I h cross. So px into I h cross plus I h cross into px. So 2 I h cross px. So this is the value of the commutator. Now if we simplify it, what we are getting? 2 I h cross into px means minus I h cross del x, right? I into I is minus 1 into minus, that is plus. So overall we are getting plus 2. We are getting 2. We are having this h cross and the h cross, so h cross square into del x. So 2h cross square del x. 2h cross square del x, right? So apart from solving this, if you remember that xpx means IH cross, then you are done, right? So this basically makes your calculation easier. So just recall a very simplified things. xpx means IH cross. So this is basically a simplified version. Now if we put x comma px cube, that was the last question. Now if you want to solve this, then you will write like this: x comma px dot px, and I have already shown you how to write. First write this two, then write this two, then this two, right? So px dot px third bracket plus If it is A, B, C, then first we have to write A, B. Then Px, Px, then A, C, then BC, BC, Px, Px, third bracket, plus. So here will be remaining terms, A or B you have written. So X and C will be there, X and Px. Here will also be X, Ax comma Px. Here will be X comma Px. So XPX means IH cross. So Px square into IH cross plus Px into IH cross Px plus IH cross Px. तो कितना IH cross हो गया? So how many IH cross are there? 3 IH cross into Px square. 3 IH cross Px square. Now look at the pattern. So we were getting here, this means 3 IH cross Px square. Now let's look at the pattern. When there is x px square, then 2 IH cross px. That means just basically it's like the differentiation of this. Px square, the differential is 2px. Px square differentiation is 2px, and additionally there will be IH cross. Similarly, px cube differentiation 3px square. 3px square and IH cross will be there. So now can we conclude that px comma x to the power n minus IH cross n x to the power n minus 1 x to the power n px equal to IH cross n x to the power n minus 1 and x comma px to the power n x comma px to the power n means x comma px to the power n means I x p to the power n means, yes, x p to the power n means IH cross into our differentiation, IH cross into n px to the power n minus 1, then px to the power n into commutating x is minus IH cross n px to the power n minus 1. Is it clear? Is it clear? Now how will you remember this? You have to remember this to solve faster quantum mechanical problems. Faster, you have to recall this. Now how you will recall it? Okay, just when px, x and px, when you write px, first comes p, then you write x. So first comes p, then comes x. If first comes p and second comes x, then first come p, second come x, then it is minus. First p and second x, that is minus. Now here the power is on x, so we have differentiated this x term. Here the power is on x, so we have differentiated the x term. Here the power is on px, we have differentiated the px term. Here the power is on px, we have differentiated the px term. So my name is Sagar. If there is power on me, then we will write n Sagar to the power n minus 1. It is like this. So two things you have to remember. First, if initially px then x, then always there will be minus IH cross will be there. Always there will be IH cross. So minus IH cross will be there. But it is x px with some power. with some power, then it will be plus I h cross. Now if power is on n, then it will be nx to the power n minus 1. If power is on px, then it will be n px to the power n minus 1. Now when we will inverse it, that is px x to the power n, we will write it x to the power n px. That means if it is ab, we know this. If we write ba, there will be minus ab. This is the basic property of commutator, basic property of operator, isn't it? Sorry, basic property of commutator. Okay, so ab commutator equal to minus ba, isn't it? So that's why from here to here I have just changed the order. Okay, then the negative sign disappears. That means negative to positive, positive to negative. So clear, no issues, no problems. So we have completed the property of commutator, and we have solved few numerical problems, and with these numerical problems we have seen their few quantum mechanical applications. See, first few lectures may be boring. You maybe at this point you cannot interpret or visualize that what is the practical implication of these equations, but with time definitely you will get it. Okay, one or two things I have practically said you, that if this operator, suppose this p x to the power n or x, if it is not zero, right? It is not zero. If it would become zero, that means on some wave function, if you first operate x, then you operate px, the result will be same on if you operate px then x, result will be same. That means two path will give the same result if they commute, but here it is not commutating with each other, isn't it? So this is not zero. That means path matters, right? So with time, obviously these equations will in your calculation, this will come a lot, this will appear a lot of times. So then it will be easier for you. So at this point, the problems, the questions I have given you here in these examples, just on a fresh page, write those question again, question 1, question 2, question 3, and in the previous class also. Just write questions and try to solve it by yourself. Try to solve it by yourself again. You can do this exercise also. Just take this 2 page, takes this 2 page, take this 2 page. Here just write question 1, question 2, question 3, question 4, question 5, question 6. Suppose one set of question paper you have made, here you have to solve this. Make it another copy, question 1, question 2, question 3, question 4, question 5, question 6. Question 1, question 2, question 3, question 4, question 5, question 6. So just solve this, then go to this page, solve this, then go to this page, solve this. So 3 times you have practiced all the questions, all the mathematical questions we have discussed. So this will make your practice a bit smoother. So we were studying the properties of operator, right? So in that properties, the 5th property maybe we were talking about commutator, and which we have finished. Okay, yes, we were discussing properties of operator. Then within this, one property is commutator. First property, second property, third property, fourth property was the observable versus operator, quantum mechanical operator versus classical mechanical observable. 5th was commutator. Then we will be going to 6th property of operator. So we are just studying the properties of operators only. Okay, so in commutator we have seen few properties, we have seen few numerical problem, and from these numerical problems we have derived some formulas. So this was our discussion. In the next class we will be discussing the next property of operator.